Yes, hello, good morning. So this time I'm going to explain about simple regression and correlation. Simple linear regression and correlation. I just want to share my screen, entire screen. All right, so here we go. I will use this. All right, simple regression, linear regression, and correlation. This is the example. It's similar to what you're going to do in your exam. I'll read it. A team of electrical engineering students is investigating the relationship between the length of wire and its electrical resistance in ohms. The team collects data from 12 different wires and performs a simple linear regression analysis. The regression output is summarized below. So, what is the story behind of this? A team of electrical students. So there is a team of electrical. They want to investigate the length of wire and the electrical resistance for each length. Okay. So is there any significant difference if the length of the wire is short? Will it have a higher electrical resistance? Or when it's long, it is lower and its resistivity? So let's see how it goes using simple linear regression analysis. Now, there are summarized information that will be given to you. R square, this is the coefficient of determination. And from the coefficient of determination, you're going to look for correlation coefficient, which is R. I'll explain that later. And also one given is a slope and intercept as well. These are what you need. And you're going to solve for correlation coefficient. You're going to solve for coefficient of determination. And you're going to predict resistance of a wire with a length of 15 meters. So will it have a high resistivity or low? Now here's the solution. First, you have to calculate the correlation coefficient. Because R square is given, I should say, 0.92. You can see that from the summary in a black background. The first one, okay? Okay. You use that to get the correlation coefficient. So, R square is equal to 0.92. Because this is an R square, you have to get the R. How do we get R here? You extract the square root on both sides of the equation. So R will be square root of 0.92. And this gives us a value of, oh, it's not here. So let's just calculate it. 0.92. Oh, I have computed it already earlier on, is 0.95. Square root of 0.92 is 0.95. Okay. So the workings will be R is equal to square root of R square, and R square is 0.92, so R is 0.95. Okay, therefore, the coefficient of the correlation coefficient is 0.95. Okay, what does it mean? If your dots are close to each other and you're going to draw a line through it, that line has a very strong coefficient, correlation coefficient. It has very strong correlation coefficient. It's near to 1 because the dots are too close to each other and they are, you can draw a straight line through them. Okay, and you can also get a slope from it. And from the line, you can get a dot there, and you can get a y of it and an x of it to determine your slope. And also, if you have a line like this one, you call this one the y-intercept and this as your x-intercept. Okay? Intercept, T-E-R-C-E-P-T. There you go. Okay. And those are the values that we need. Y-intercept is the intersection of the line through the y-axis. And R, that will be the correlation coefficient that you can determine from the plotted dots. Now, how do you compute for R? There is a formula that we can use for that, and that is 1 minus SS residual and over SS total. And how do we get for the SS residual? You have the summation of y observed minus y predicted. You get all the values and then square it, and you get 0.6064. Here, for the SS total, you get the summation of the y mean minus y. Y here is observed. So how do you get the y mean? You have to sum up all the y observed, divide it by the number of observation, then you get your y mean. And then you get this, the y min minus y min minus y min minus another y. So these are all the data. Sum this up and then get the average. You get 203.2056. You substitute in the formula, then you get 0.997016. This is actually your R squared. If you get the square root, you get 0.998507. But you will not do this in the exam. Instead, this data is already given. I just have shown to you so you will know how they were taken. But those are not the data that was analyzed for this example. Right. Next one, number 2, is to predict the electrical resistance for a wire. Hang on. Predicting the electrical resistance for a wire with a length of 15 meters. Okay, you will be using a regression formula. This regression formula is taken from the equation of a line, which is y is equal to mx plus c, where m is the slope. Okay, our slope is delta. The slope, which is m, is equal to delta y over delta x. Delta y is y2 minus y1 over x2 minus x1. Okay, let's look at this example. I have a line here, line A, all right, line A. Okay, and I drew a triangle parallel to the x-axis, parallel to the y-axis to get the slope. Then there will be some points to consider here. How do you get 5 and how do you get 100? Or how do you get the height of the triangle and the base of the triangle? Draw a line from that point that touches the line of best feet. This is actually a line of best feet. Okay. Draw a line from this point down to the x-axis and call this one as your y2. Draw a line down to the x-axis and you call this as your y1. So y2 minus y1 will give you the difference. That is your delta y. Same with x. x2 until here, that is x2. And here will be x1. And if you're interested of this, which is the base of the triangle, it will be x2 minus x1. Okay, so that's your slope. But then again, you're not going to do that in the exam because all the informations are already given. Okay, so you have a slope of 0.05 and a slope and an intercept of 1.2. There. The slope is given, the intercept is given. So now from the formula y is equal to BO or beta O, beta 1 times x, then you have a working formula which is y equal to 1.2 plus 0.05 x. This is the one that you're going to use to predict any y of a value x. You're going to input here a value and you're going to calculate y. Okay? Now, linear regression and correlation is specifically used to predict activities or predict what's going to happen after some time. Okay? So, let's now move to the prediction. Oh yeah. Sorry for that. Okay. Predicting the electrical resistance for a wire with a length of 15 meters. So our formula a while ago was y is equal to 1.2 plus 0.05 times x. Okay. And this is the one. So because we need to know what's the resistance after 15 years, then y is equal to 1.2 plus 0.05 times 15, then you get 0.75 for these two quantities. So solving 1.2 and 0.75, you get a value of y, which is 1.95. So the predicted resistance of the wire with a length of 15 meters will be 1.95 ohms. And that is what a simple linear regression and correlation is. To summarize, for a linear regression and correlation, you need an R square. That is what is given. In this case, it's 0.92. You need a y-intercept, which is 1.2. You need a slope B1, which is 0.05. And then you need the formula. Y is equal to BO plus beta 1x. And using this line or linear regression, you can solve for any y value given a value of x. So don't worry, in your exam, BO, B1 is given. You just have to compute for y and x. And R will also be computed as an additional requirement, just so you know if the R that you have computed is a weak relationship when R is negative, a strong relationship when the dots are near to each other, moderate positive relationship when they are far apart a bit, but they can still give you a fashion, a straight line fashion of the line, and you will know whether it's a very weak positive relationship, positive because they are going up to the right, but weak because they are too scattered, and you do not know where to draw your line. But here I can see that there are more dots on the area, so I can draw it like that. In that case, you will have a y-intercept here. Okay. All right then. So this is what we. There you go. So I just have explained simple linear regression and correlation, and you apply that in your exam. Have a blessed day. Enjoy your Saturday, and bye bye.